Today we'll introduce some interesting characteristics about why animals form groups. When desert locusts are well fed, they're solitary creatures. But when food becomes scarce, hungry, desperate locusts crowd onto small patches of land where they can still find something to eat. Contact between different locusts' hind legs set off a slew of reactions that change their appearance and behavior. Now, instead of shunning their peers, they seek each other out. The locusts eventually start marching and then fly away in large numbers seeking a better habitat. These gigantic swarms can host millions of insects and travel thousands of miles, devastating vegetation and crops. They stay close to each other, but not too close, or they might get eaten by their hungry neighbors. When many individual organisms, like locusts, bacteria, anchovies, or bats, come together and move as one coordinated entity, that's a swarm. From a handful of birds to billions of insects, swarms can be almost any size. But what they have in common is that there's no leader. Members of the swarm interact only with their nearest neighbors or through indirect cues. Each individual follows simple rules. Travel in the same direction as those around you, stay close, and avoid collisions. There are many benefits to traveling in a group like this. Small prey may fool predators by assembling into a swarm that looks like a much bigger organism. And congregating in a large group reduces the chance that any single individual will be captured. Moving in the same direction as your neighbors saves energy by sharing the effort of fighting wind or water resistance. It may even be easier to find a mate in a swarm. Swarming can also allow groups of animals to accomplish tasks they couldn't do individually. When hundreds or millions of organisms follow the same simple rules, sophisticated behavior called swarm intelligence may arise. A single ant can't do much on its own, but an ant colony can solve complex problems, like building a nest and finding the shortest path to a food source. But sometimes, things can go wrong. In a crowd, diseases spread more easily, and some swarming organisms may start eating each other if food is scarce. Even some of the benefits of swarms, like more efficient navigation, can have catastrophic consequences. Army ants are one example. They lay down chemicals called pheromones which signal their neighbors to follow the trail. This is good if the head of the group is marching towards a food source. But occasionally the ants in the front can veer off course. The whole swarm can get caught in a loop following the pheromone trail until they die of exhaustion. Humans are notoriously individualistic, though social, animals. But is there anything we can learn from collective swarm-based organization? When it comes to technology, the answer is definitely yes. Bats can teach drones how to navigate confined spaces without colliding, fish can help design software for safer driving. And insects are inspiring robot teams that can assist search and rescue missions. For swarms of humans, it's perhaps more complicated and depends on the motives and leadership. Swarm behavior in human populations can sometimes manifest as a destructive mob. But collective action can also produce a crowd-sourced scientific breakthrough and artistic expression, or a peaceful global revolution.